Hi, I'm Davi, Head of Customer Success at 2057. We're a software development house and have built two low-code tools, Stadium, which is a rapid, data-driven web app builder, and Links, which is a back-end integration and automation tool. Today I will be using Links as part of my example. Today I want to take you through a journey of an app, a typical Hello World app. When we talk about a modern Hello World app, there are a couple of ground rules we need to lay down first. Firstly, an app can be a web app, a mobile app, a PC app. They're all the same. Then, no modern app lives in isolation anymore. They need to talk to each other. They need to talk to other systems. Most apps use some form of web services, whether it's REST or SOAP, GraphQL, etc. What about connecting directly to a database? No, just don't do that. You don't want your clients to walk around with direct access to your database. So, what is low-code? I'm sure most of you are familiar with low-code, but in essence, it's building a solution without physically coding. So all of these examples are available on our GitHub, so please follow the link on the screen or contact us if you want more information. So, introducing Abby. Firstly, it's Abby because it just sounds better than Appy, and she's a brand new app. She just woke up and wants to say hello to the world. She got no other purpose but to help us, to show a quick few tricks on how to use low-code to build a contract and a backend for an app. So let's just jump into it. Firstly, Abby will perform a standard hello world. There's no connection to anything, simply saying hi to the void. So how do we get her to speak to other systems? The answer is by providing her with an interface defined by a contract. A contract is in the most basic sense is a document which tells you what the relationship is between parties, what they may or may not do, and what they get. Exactly the same when it comes to web service contracts. So by using a low-code tool like Links, let's build an interface and give Abby a contract to use. Okay, so when we go into Links, you'll see that we start with a brand new solution, and we'll add a folder called types. This is where we'll add all of the types for our project, and we want to use the REST plugin because we will be using REST services as our API. We want to use the simple REST host component. We'll call this a REST API, and then the base URL is where Abby will connect to our app. So we'll just use a normal HTTP port and call this Abby API 1. Then for us to show her the contract, we will enable the Swagger user interface. And now we can define our operations. First, we want to create a new response type for our first service. We'll call this hello response. And for that we will need two parameters, a success parameter and a message parameter. Now we can go to operations and add a new operation called hello, and it's the same path, hello. It will be a get operation, and all we will get as an input is the username, and as an output as the output we will define our hello world response. Now you can see we've got a new operation called hello, and all this operation needs to do is to set an output. So we'll do set value output, set value response, and we select our response body. The success would be true, and then we can set up a message. So we go expression, and the message will be hello, and we'll give it the username that we get as an input. And then we can also say this is the Abby server responding, and save. And that should be it. We can debug our solution. Now once we are debugging, our web service will be available at the URL that we've defined, so Abby can connect to it straight away. Once we've set our API live, we can actually go and view our contract, and we can see that we've got one operation called hello with a success and a message. For Abby, you can see that we are using React code. In React, we are using Axios to call our REST web service. The path is hello, and the username is the only input that we require. And then at the end, when we get a response back, we can take the message and use it on our app. So going to Abby, we're going to step 2. The name for this step is hello, and we can just enter the name. We'll use Davi and send the name. You can see our server then responds. Hello Davi, this is the Abby server responding. Let's try again. Let's add John, send it through. You can see hello John, this is the Abby server responding. Let's try another one. Let's say Sally. And it says hello Sally, this is the Abby server responding. At this point, Abby is only talking to our server, not to the world yet. So for us to enable her to talk to the world, we will need to add a couple more APIs. So the first one is we will be using the Wiki Open Search API. So we go back to links. We add a new type, call it Wiki Response, and this will return a list of famous names. Save that. We go into operations and we add a new operation called as famous names, and the path would be the same, famous names. The query parameter will be a username, and the response will be our new wiki response under our types. We save. Now we go into our new operation and we call REST endpoint. So here we are calling the Wiki API. We've got the link from the wiki site. The query, we need our search parameter, which we get from our username. The action will be open search. And our format would be JSON. Now the wiki response is not perfectly structured, so we will need to edit it a little bit. First we want to remove the first bracket from our response, so we just do a quick remove, and then we just want to extract the list of names. We don't really need any of the other information. So we take the response and we take the string from the first bracket up to the first closing bracket. This would be the complete list of names that we get from the wiki. And then once this is done, we can then save this as our output. So let's test this. So if we use my name and we run this as a debug, you'll see that we get a success back with a lot of data, and then the rest of our operation removes the data around the brackets and we sit with only the list remaining. Okay, so let's go back to Abby. We click on step 3. Hello, are you famous? Right, so let's enter a name again. Let's enter my name and see what we get back. If we send my name, we'll get a list from Wikipedia, but you can see my name is not on the list of Wikipedia. But that's fine. We can do a couple more, so let's try another one. Let's use John this time. Okay, we get quite a few names again from John. Let's try another one. Let's use David. Okay, and we've got a couple of David names as well. So when I told Abby she is an SPA, a single page application, she heard spy, which is nice. So let's do a bit of spying. We'll be using two more APIs on the names that we received from the Wikipedia list just now. We'll use the Google Image Search API, and then after that we will use the MS Azure Face API and compare the images to see if they are the same. If we go back into links, we can then set up our Google Image Search. So we've got a REST web service call again. We set up the URL that we get from Google, and then we need to set up some query parameters as well. So the important parameters here are Q, which is the query that we are sending to Google, which is the name, and then also the search type, which is image. Okay, and then we save. Google will then send us back a list of items, and we can just assign those items to our list, to our response. And then the same with the Face API. First we will get a file from Abby, and we will send that file straight to Azure. And then also we got a link from Google for another file, and we send that to Azure as well. And then we set up both of them and verify them with Azure to check if they are the same person or not. Let's go play with this in Abby. So if we go to step 4, which is spy mode, here we can then enter a name. Let's call this first one Davy again. We send the name to Abby. We get back our list of names, and we get a photo of the first person on the list. And then I've got my photo as well. Now let's verify whether these people are the same or not. If we click on verify these faces, it gets sent to Azure, and Azure will send back and say, no, these are not the same people. They are only about 17% the same. Okay, so let's try again. Let's try John, and send John to Abby. Again, we get our list of names. The first name on the list is John F. Kennedy, and we get a nice photo from Google. And then let's verify them again using the Azure API. Azure will then come back and say, no, these people are not the same. They are 24% related. Okay, let's try again. The next one, then let's try Sally out of interest. We get the list again. The first name on the list is Sally Rooney. Okay, this is the photo we've got from me, and let's verify them and see if they are the same person or not. Okay, so are the people the same? No, they are not. Okay, and we can continue like this. So by now you would have noticed that the structure is mostly the same every time. We first get a request from Abby going to our API. Our API would do a call to another API and get information, and then provide that information back to Abby. So let's try one last one. We've got faces. Let's see if we can have a reunion with these people. So first we will set up a Google call to the Directions API. From this we will get back a list of steps, and then from these steps we will add them to our output, which we will then use inside of Abby. If we go back to Abby, we click on step 5. Let's try a couple of names. So let's try John first. If we send this name, get back from Abby a list of names. The first one on the name is John F. Kennedy. And we can then verify the faces again. Is this the same person? No, but I found an address for John F. Kennedy, which is John F. Kennedy Boulevard. And then we get directions from Google, and it will give us nice directions step by step how to get to John F. Kennedy Boulevard. Right at the end, turn right into John F. Kennedy Boulevard. Let's try another one. Let's use David. Okay, so again we get a list of names. On top of the list is David Bowie. And let's verify the faces again. Is this the same person? No. Our close today, 20%. And we've got a David's Drive. So let's do directions to David Drive. And then Google will return us the step-by-step directions to get to David Drive. Turn left onto David Drive. And that's it for the example. It basically shows you how you can create a full contract using low-code. And this contract can contain all of the elements and evolve through time. In this example, we used the hello operation. We've used famous names, face search, directions, location, and verify. And our app have used these operations to get data from the internet and show them on our app. So in summary, apps need contracts. The better you define your contract, the easier the interaction will be between your app and the world. Low-code is a brilliant tool for setting up a backend for your app. It's fast, flexible, and easily maintainable. You want to remove code complexity from your app. Let the server do the hard work for your app. Thank you. Signing off from Africa, and please let us know if you've got any questions.